Today we'll be looking at how we can solve simultaneous equations using matrices. We have a question here that says solve the simultaneous equations below. X plus y equals 7, that's our equation 1, and x minus 3y equals minus 9, that's equation 2. So if you want to solve a simultaneous equation using matrices, what you do is you have to create a matrix using the coefficients of x and y and the constants. So the first step is to create a 2 by 2 matrix. That's a matrix that has 2 rows and 2 columns. So we created 2 by 2 matrix using the coefficients of x and y in both equations, starting from the top. So in equation 1, the coefficient of x is 1 because x, we don't have any number there, so there's a 1 there. So the coefficient of x is 1, so we'll bring it here. And then for y, the coefficient of y is also 1, so you have a 1 here. In equation 2, the coefficient of x is also 1, so we'll bring that 1 here. And the coefficient of y is minus 3, so we'll bring the minus 3 here. Now we'll find the determinant of the matrix. The determinant of this first matrix we created using the coefficient of x and y, we will call it theta naught. The triangle naught is called theta naught. And so to find the determinant, what you do is you take 1, this 1 here, you multiply it by this number here, you go this way, so 1 times minus 3, and then you subtract from what you get multiplying this way. So you go this way first, 1 times minus 3, and you subtract from this way, 1 times 1. So if you go ahead and do that, we'll have minus 3 minus 1. So 1 times minus 3 is minus 3, and 1 times 1 is 1. But then we're subtracting here, so you have this minus sign. So minus 3 minus 1 is minus 4. So our theta naught is minus 4. And then the next step is to create another 2 by 2 matrix by substituting the constants. The constants are the two numbers you have on this side. These are the constants. So what we do is we create another matrix by substituting the constants for the coefficients of x to get another determinant, and this determinant is going to be theta x. So instead of having 1 and 1 as we have here, we substitute the 7 and minus 9 here for the 1 and 1, so we have 7 and minus 9, and then we find the determinant, which is triangle x or theta x. So do the same thing we did previously, 7 times minus 3, and then we subtract minus 9 times 1. So if we go ahead and do that, we have 7 times minus 3, that's minus 21, minus 9 times 1. Minus 9 times 1 is minus 9. So minus 21 minus minus 9. That's going to be what? That's going to be minus 21 plus 9. Because minus times minus is going to be what? It's going to be plus. So minus 21 plus 9 is what? Is minus 12. Okay? So theta x is minus 12. The same thing we did in the previous slide to find theta x, we're going to do here to find theta y. But now instead of having 1 and minus 3 here, we now have 7 and minus 9. We've replaced the constants for the coefficient of y. So in this case, the determinant is going to be theta y. So now we find the determinant theta y or triangle y going this way first. 1 times minus 9, then minus 1 times 7. So if we go ahead and do this, we have 1 times minus 9 is going to be minus 9, and 1 times 7 is going to be 7. Then we have the minus here, so that's minus 7 minus 9. Minus 9 minus 7 is going to be minus 16. So theta y or triangle y is going to be minus 16. So now to find x and y, which is what the question wants us to find, so by solving the simultaneous equation, we use this formula here. Y is going to be theta y over theta naught, or triangle y over triangle naught, and our x is going to be data x over data naught. And we already have our data naught is minus 4, and we have our data x is minus 12. So our y is going to be data y, which is minus 16, over data naught, which is minus 4. So if we go ahead and divide here by minus 4, we have 4 as our answer. Y is equal to 4, because minus times minus cancels minus here to give us plus. 4 here 1, 4 here 4, so our y is 4. And then our x, data x, which is minus 12, over data naught, which is minus 4. So that minus 12 over minus 4 is going to be 3. So our x is 3 and our y is 4.